Hello, I'm Andrew Smith from the Open University Cisco Academy, and in this video I'm going to be covering the heady subject of SLAC and DHCP v6 for TM257, which is part of the Switching, Routing and Wireless Essentials. As ever, I'm not going to read through the slides verbatim. You can read them. You're basically able to do that. As you would have learned on Introduction to Networks, a global uniclass address is manually configured on the device. This is a locally significant IP address that is used between devices on the network. The example given here is obviously Windows, but obviously you can do this on most devices. But what is quite important is there is also the host link local address, which is the routable address, and basically it uses a router advertisement to see if any other devices has got the address that it's got. In IPv6 you would assume that with the large numbers of addresses available, if I randomly allocate myself an address, nobody else will have it. However, probability is a fickle beast, and you know that there is the potential for other devices to have it. It does an IPv6 ARP, and then if through address resolution protocol there's nobody else with it, then I get to keep my address. If somebody else has got it, I will randomly allocate myself a new address. And because of that, we actually have two ways of doing dynamic host address allocation using IPv6. That was a bit of a mouthful there. We either have the stateless or the stateful, where the stateless uses SLAC, basically stateless address allocation, where basically it uses stateless address allocation using router advertisements within its own domain to make sure it's got an address and you can actually follow those rules. Or you can use SLAC with a DHCP server, which means that you can then control the allocation of addresses within a set domain. So they randomly allocate, but you can start giving out information. So you can start setting certain rules within that domain as well. Or you can have stateful, where you've got full control. So I've actually set up a network that I'm going to be doing at the end of this video as a separate video, where it will actually demonstrate the stateful configuration as well. This means that you can have a sort of wide range of dynamic situations, and it does mean then that in a network where you might have a lot of IoT devices, you either can let them all join in any fashion you desire, or you can have some control within the system, or you can have total control. So no control, some control, and total control. And I think that's the best way to sort of consider stateless versus stateful, or SLAC only, or SLAC with DHCP, or totally DHCP. Because of that, within SLAC there are three types of router advertisement messages. There is the auto configuration, or the other configuration, or the M flag. So A is stateless, O is stateless with DHCP, and M is basically DHCP only. And that way it has the same type of negotiation principles as its older DHCP version 4. So let's look at SLAC. SLAC, as I've already described, is either randomly allocated or randomly allocated with control, and you can set it up that it will have some configuration. I've repeated myself quite a little bit here, but it goes through an update process every 200 seconds, and it's just going around saying, this is my address, does anybody else need to know about this? And then that way, if there is router solicitation messages taking place, then a DHCP v6 device could communicate that. And what we've got is a situation where it's designed for devices that may or may not need to have address control within an environment. To enable Slack, you've got to set up both the link local and the unicast address on a network so that it will actually take place, but you must configure on the router itself the IPv6 unicast routing. So based on the normal config, you've got to set up unicast routing so that Slack will communicate, and then it will allow that to become a routable IPv6 address. And once you actually check on an interface, any interface that is configured correctly will show that it's joined the unicast groups that are then routable out of the network, or workable within a dynamic host setup. You need to set the flag, and you can set the flag by configuring the router, and the router, you'll actually discover that these modes are actually set in within the interface within the router that's going to be configured. So that when the router solicitation messages are communicated out across the system, it will know what it has to do with the addresses. So for interface IDs, it can be totally random, or it can use a component of the unique identifier within a MAC address. And you'll discover that Packet Tracer uses EUI64 to actually do this in a lot of its examples, which means that you can also tweak the MAC address and therefore control the host given identifier as well. Pros and cons to either methodology, because obviously randomly generated works for a lot of Docker and virtual machine and Kubernetes and Lambda instances, if that is what you need for a cloud solution. Okay, and as I've already talked about, and yeah, there is a little bit of repetition in the slides, there is a random address detection methodology to see if somebody else has got the address. I mean, reality is addresses that you are likely to hit another address within a subnet is very, 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 very remote. However, let's think common sense. Yeah, the maths is there. It is possible, and we don't want that situation to happen. And as IPv6 grows, by the time that we're all really old and everybody's now got internet-enabled biometric implants or something to for assisted living, then the probability increases each time. So DHCP v6, you can see the language changes from v4, but the principle is almost exactly the same. It starts with a router solicitation, it responds with a router advertisement, then it sends out a solicit message, then there is an advertise, then there is a response, and then there is a reply. Okay, and it's working on UDP, just on 546 and 547. And as long as you've set the flag correctly, and you've set it for what you want, whether it's an O or an M. So obviously O is working with the stateless, M is working with the stateful. It will actually run the DHCP protocol quite comfortably. What you have to remember though is if you're running stateless, you've got to turn it on the interface. Okay? So it's very much interface driven and just pointing out to the interface that is on the network that you want this to happen. So you don't set it up central to the router, you set it up on the interface and the interface only. So if you're thinking of routing on a stick and sub-interfaces, you actually have to set it up on each sub-interface where it is applicable. Something that is sometimes caught out students. For stateful, you actually set it up with the right flag, you set it up with the M flag, and you would actually set it up in a very similar way that you would actually set up DHCP v4, but you've got to tell the interface now that you're using a managed config flag. So you've got to tell it that it's the right flag, and then when you've got the right flag, you can actually set up the configuration. So no flag, or the A flag is stateless, the O flag is stateless with DHCP, and the M flag is obviously stateful DHCP only. So set up the server. You'll discover all the similar principles to our friend DHCP v4. Now you set up the unicast routing, which we've shown you in the previous slide, and then we set up the DHCP pool, and then we dish out all the other useful information like the DNS server, a domain name, and stuff like that. Because remember, the addressing has already taken place. You've actually set up the rules for the addressing as well. And if you're actually going to look at the configs that I'm going to do in the video after that, you can actually set up a router as well to be a stateless or stateful DHCP client on the network. So you can start putting a whole set of hosted routers in there as well. And my example has got a couple of PCs and a router all learning these addresses off of the DHCP server. The configure. So we set up the pool, we set up the server with the pool name, and we actually tell it which interface that we're going to push it out on as well. So you've got to bind interface to the pool in this situation. So again, it's very interface driven. If you don't bind the interface, it won't handle any DHCP for version 6, which means that then you've got, you could actually have some granularity, or you could have some missed out interfaces, or you could have some IPv6 routing problems as well. And to actually check that, all you've got to do is just tell it that it's going to use IPv6 address DHCP. Usual verification commands, it's actually very similar to v4, but obviously you stick IPv6 in the way, and you've got v6 DHCP pull and v6 DHCP binding. Okay. And finally, the relay, you always put it on the interface that is learning, telling it from the network it's learning from, as long as that network is routable and learned within the routing table of the router that you're configuring. And again, you can just do a show and show the interface, or show all the bindings. So a little bit of a waffly lecture from me, because basically there's a lot of circular logic going on here, but what you just need to understand is it's stateless with DHCP, and stateful DHCP only. And you can actually run the network totally stateless, but if you want to have control or dish out information, often it is DHCP or stateless with DHCP. And you see I keep getting the language mixed up, because in my head I'm trying to sort of remember each of the different methodologies. And my advice to you is read through the slides, read through the content, listen to the video, and read through the content again. So thank you very much. I'm Andrew Smith from the Open University.